Welcome to the Level 10 181 Fremont job site. What you're about to see is something that has not been done in the city before. The job site team here, led by Chris Wilcox, Senior Superintendent, has basically invented a system that is going to offer perimeter protection for what could be a typical load falling off a building. Something as small as a cell phone falling 200 feet could have a catastrophic effect on anybody that it hits. We are doing a fall protection, or an object protection system, I should say, to anticipate catching what should never come off the building. Level 10 construction has a core value of safety, and that includes everybody that works on the site and everybody that we may encounter or walk next to the site. At this particular job, we have a daycare center that is approximately 20 feet away from us that we are going to be building over 700 feet above the daycare center. We're going to have construction crews for a year and a half working on this space, and unfortunately in that time somebody could make a mistake, and we are putting a system in place to prevent that mistake from catastrophic consequences.
Hello, my name is Ian Simon, project engineer with Level 10 at 181 Fremont. Today I'll go over the engineering pieces and parts, nuts and bolts, and net for our inner safety netting system for the drop test today. The way we will measure the system is a system of tension and compression load cells here at the reactionary positions of the beam. At the bottom we will have compression tests inside steel collars, all custom fabricated as a miscellaneous metal. The wire will show you where the compression load cell is, right here at the base. We will then measure tension of the cantilever system at the very top, with the tension load cell and the netting being connected from each side. The netting itself is double layered woven fabric with 2 layers of porous spaces. A small porous space for your small miscellaneous objects such as your pens, nuts and bolts. A larger porous space to help support the small fabric with larger pieces such as tape measures, cups, non-attached items that fall off the building. As we look at the main structure, the cable is 5/8 inch thick cable. The netting is bought out at a 20 foot by 40 foot section, but engineered to have slack in it. What you buy is not actually 20 feet by 40 feet. The engineered slack allows the netting to work and absorb the force from the falls. We'll calibrate the system with a 500-pound metal weight from ABM Scale, who provided the compression and tension load cells. They will calibrate the system so that each load cell reads the values independently. Once we are done calibrating, we will then drop 400 pounds of sandbag, as requested on plan from Plan B Engineering, and drop it from 25 feet. That will allow Plan B to grab the readings and design the overhead protection over the town hall building as described by Rick Seifert. That will give the raw data for Plan B Engineering to understand what this engineered netting is capable of, and will allow us to protect daycare and historical town hall building just 14 feet away from our containment wall. This is Ian Simon. Enjoy the show. The 3 drops that we performed were success. The difference in forces weren't very different. We found that the conclusions that we have deformation in the net. The net would need to be changed out after an incident. Inspections will need to occur with the connection points and cables, carabiners, shackles, and the netting connections within the net to make sure there's no tears. The debris net will also tear during a serious incident and will need replacement, as well as the regular net, but the debris net will fracture immediately after a large impact. The whole system, the steel was stout, operated effectively, and it will catch 400 pounds at 25 feet, no problem. We will send our data to Plan B Engineering, and we will be able to design safe overhead protection for Town Hall. This is level 10, where we build and create safety at the highest level. Thank you.